How are you, learner? Welcome to our physics lesson. Our topic of today is a continuation topic in Form 2, that is turning effect of a force. Turning effect of a force, or turning effect of force. And in our previous lesson, we were able to define moment of force. Moment of a force. And we said that when we talk of moment of a force, it simply refers to the turning effect of a force. We were also able to give some examples of activities where force produces a turning effect. And lastly, we were also able to look at another definition for moment of a force, and this now where we are going to continue from in our lesson today. So we are continuing with moment of a force. And in our lesson, we are going to calculate moment. Now that we have already defined moment of a force, we'll now go into calculations. So by the end of this lesson, you should be in a position to calculate moment in a given question. And number 2, we are also going to look at principle of moment. And in this, we are going to state the principle of moments. And therefore, by the end of the lesson again, you should be in a position to state the principle of moments. Now, moment of a force. We defined moment of a force, and we defined moment of a force as the product of force So we defined moment of a force as the product of force and the perpendicular distance from the point of support to the line of action. And therefore, we were able to write the formula for moment as force multiplied by distance. And we said that force should be in newtons, distance in meters, and therefore the SI unit for moment is Newton meter. So we want to do some examples. We want to do some examples on calculation of moment. So examples, we can look at 3 examples. So you are told, find So we are told find the moment of the force about point O. This is a point O in the following figures. So we start with the first figure here. A, we have the following. So we have this figure here. This is point O. And on this point here we have a force. And the force is equal to 10 newtons. Then we've also been given this distance. So we have been given this distance as 10 centimeters. So that is the question. So we want to find moment of the force about point O in this figure. So as we can see, at this point O, and we are told that this is the pivot. So this is our fixed point, point O, and we have a force here. You can see that the force is perpendicular. From the point of support to the line of action, we have perpendicular. This is a perpendicular distance from here up to here. So we want to calculate moment. And we know very well that moment will be given by force, and force in newtons multiplied by distance, and distance should be in meters. So we have our perpendicular distance, 10 centimeters, and the force is 10 newtons. So our distance is 10 centimeters. We need to convert it into meters. We know that 100 centimeters make 1 meter, and therefore we just come and divide 10 by 100 to make it in meters. So we are going to end up having 10 newtons multiplied by 10 all over 100 meters. We can cancel this. So we end up getting our answer as 1 times 1, which is 1 Newton meter. So our moment is 1 Newton meter. And we have been able to get it from, we have our force here multiplied by the perpendicular distance from the point of support to the line of action. This is what we referred to as the line of action. And you can see the distance that we are using is the perpendicular distance. This distance is perpendicular from the point of support to the line of action. It's a perpendicular distance making an angle of 90 degrees. We can look at another example, number 2. We are still calculating moment. So in part number B, we have the following figure. So this is our fixed point. We have point O here, and then we have a force acting on the opposite direction, and the force we are given as 30 newtons. We have also been given the distance, this distance here. The distance here we have been given as 20 centimeters. This distance is 20 centimeters. And we are told that this is the pivot. So that's what we have. We want to calculate the moment. So when you are told to calculate the moment, the first thing we need to write the formula for moment. So moment will be equal to force multiplied by distance. So we need to ask ourselves, what is the force? We have a force of 30 newtons. Then what is the distance? And now, remember we are talking of the perpendicular distance from the point of support to the line of action. So we need to know, where is our point of support? Our point of support is here. Where is the line of action? Our line of action is here. This line of action. So if I may ask you, what is the distance between from the point of support to the line of action? What is the distance there? The distance is 0 because the force is being applied at the point of support, and therefore the distance covered is 0 meters. We can talk of meters, 0 meters, and therefore our moment will be 0 Newton meters, meaning that there is no turning effect. This can be seen whereby if you try to apply force on the hinges of a door, you apply force on the hinges. What is going to happen to the door? There is nothing that is going to happen to that door. It is not going to open, nor is it going to close, because you have applied the force at the hinges, at the point of support, and therefore the distance is 0. So our moment will be 0, meaning that there will be no turning effect. I think that is clear. So finally, we can do another example. Number C, we have the following figure. We still want to calculate the moment. So that's what we have. And we have been told that the distance is 5 meters from this point here. This is where our pivot is, this point O. And we have been told that the distance from the pivot to where the force is being applied, you can see how this force is. Look at the force. Here we have the force, and the force is 6 newtons. The distance here, this distance we have been given as 5 meters. This distance is 5 meters. We've also been given this other distance here. We have extended this from this point, and we have been told that this makes an angle of 90 degrees, and the distance here from this point all the way to this point we have been given as 3 meters. We have 3 meters, and now we want to calculate the moment. So you can see in our case here, we are having the point of support here. We have the distance from here to this force, but this force, as you can see, is acting in this direction. So you can see that this distance from here up to here is not the perpendicular distance. From the point of support to the line of action, our perpendicular distance is this. This is the perpendicular distance. So we are going to consider this perpendicular distance from the point of support to the line of action. This is the perpendicular distance D. So make note of that. So the distance that we are going to use is the distance which is perpendicular to the line of action. So we need to calculate this D. We know that these are right angled. We have 5 here, we have 3, and we have this side. So then that means that this is our hypotenuse, 5. Then we have one of the sides as 3 meters. We want to get D. So using the Pythagoras theorem, we'll have that 5 squared will be equal to 3 squared plus D squared. So we are going to have this as 25 equal to 9 plus D squared. So when we make D squared the subject, we are going to have that D squared will be equal to 25 minus 9, which is 16. So our D squared is equal to 16, and therefore if we have D squared to be 16, then we can find the value of D. So D squared is equal to 16. We find square root on both sides. So our D will be equal to the square root of 16, which is 4. And in our case, we have it in meters. And therefore, we can now come and calculate moment. So moment will therefore be equal to force multiplied by the perpendicular distance from the point of support to the line of action. So our force being applied is 6 newtons, and the perpendicular distance, we have gotten it to be 4 meters. And therefore, moment will be equal to 24 Newton meters. Is that one clear? So when you calculate moment, you need to remember that we use the perpendicular distance from the point of support to the line of action. And moment is given in Newton meters. Again, if you look at this example here, when you apply force to the fixed point, or you apply force on the fixed point, there is no turning effect that is going to be obtained. So that's why in our case here, if the force is being applied at the same point where the pivot is, then we are going to have a moment of 0, meaning that there will be no turning. And that's why we were saying the more the distance from the hinges, the more the moment. And simply when we talk of the more the moment, it simply means the more the turning. And that's why we were saying that the hinges of a door are placed as far as possible from the handle or from where you open the door from, so as to lead to more turning, because the moment will be more. And that's why there will be more turning of that door. So that is on moment. You can get more questions on moment and calculate. So this will usher us into now a principle which we refer to as the principle of moments, and that's what we want to state. So we look at the principle of moments. the principle of moments. And I want us to consider the following. I want us to consider this bar here, which is being balanced by several forces. This is to help you understand the principle of moment so that we don't just state it, but you know where we are getting it from. So here we consider this bar. There is a fixed point here. This is our pivot, or what we are calling the fulcrum at this point here. So this is what we have. Now, we want to apply forces on all sides of this bar here. Now, we can start with a force at this point here. So if we apply a force, we can call it force. We can call this force F1. The distance from the pivot to force F1, we can call it D1. So these letters are standing for values, certain values. So if we have this distance, we can call it distance D1. Now that is one force which is bringing about a turning effect on that bar. Now, if we have this single force on this side of the pivot, if it is applied, how will this bar, we are calling this our bar, how will this bar turn? In which direction? Is it clockwise or anti-clockwise? So if it is only this force, then we are going to have it turn this way. So which direction is this? This is clockwise direction. So it's going to bring about clockwise moment. So I want you to make note of that. So if we were to calculate moment for this force, we are going to calculate it as follows. So the moment will be equal to the force, which is F1, multiplied by the distance, which is D1, which will give us F1 D1. So that's what we have, and we have seen that this is a clockwise moment. So this is clockwise, because if we have this single force, it's going to make the bar turn in a clockwise direction. Now let's say we have another force on this other end. Let's see what will happen. So if we have another force, we can even have it at this point. So we are having it towards the left side of the pivot, downward. So if we have another force here, we can call it force F2, force F2, and therefore the distance from this force F2, the perpendicular distance from F2 to the pivot, this distance, we can have it as D2. So we have distance D2 there. Now, assuming that we have only that single force, F2, being applied on this bar. So here we have the pivot, somewhere here, and then we have a force F2 being applied. How will it turn? It turns in this way. So it will turn in this direction, and that direction is anti-clockwise. So it will bring about clockwise. It brings about anti-clockwise moment. So if we come now and calculate the moment there, we are going to have the moment given by F2 multiplied by the distance D2, which is going to be F2 D2. And we have seen that that moment is anti-clockwise. So we need to make note of that this is anti-clockwise. So this moment F2D2 is anti-clockwise, whereas moment F1D1 is clockwise. Now if we add some more forces, we can add some more forces on the upper side. We can, for example, add another force at this point here. If we have another force here, we can call it force F3 because we have F1, F2, we can put F3. So if we have force F3 here, and the distance from the force, that is the line of action to the point of support, let's say our distance is D3. This distance from here up to here, we call it D3. Now, if we have such a bar and we have a force, this is what we have. Here is the pivot. So if we apply an upward force at this point here, how will it turn? So you can see how it turns. Which direction is this? It will turn in anti-clockwise direction. So it turns in anti-clockwise direction this way, in anti-clockwise direction. So we can say this is anti-clockwise. This is anti-clockwise. So make note of that. Finally, we can add another upward force on this other side. So we can add the force somewhere here. So if we have the force here, we can now call it F4. Since we have F3, F1, F2, so this is our F4. And the distance, we can call it D4. This distance is D4. Before we calculate or before we state whether it is clockwise or anti-clockwise, we need to note that with F3, D3, as our moment, we need to come and note it down here. The other moment that we have been able to get, the moment brought about by this force F3 is going to be given by F3. Force is a capital letter F. F3 multiplied by D3, which is F3 D3. And we have seen that it is anti-clockwise. So we need to know that this one is anti-clockwise. And finally, we are having another moment being given by force F4, D4. So we have F4, D4. So we also need to ask ourselves, is it going to bring about clockwise moment or anti-clockwise moment? So when you consider that we have the pivot here and we are applying force in this direction, as you can see, how is the bar turning? It is turning in this direction, and that is clockwise direction. So we have this other one in clockwise direction. So this is clockwise. So our moment here is clockwise. Now, if we combine the clockwise moment, we want to combine the clockwise moment, so we'll write down the clockwise moment. Clockwise moments. We have the first one, F1, D1, and the second one is F4, D4. Then the anti-clockwise moments. And clockwise moment, we have the first one here, which is F2, D2, and the other one is F3, D3. Now you can see clearly that if the pivot is here on this side, downward is clockwise. Any force on this side is clockwise. On the left side, the left-hand side, any force downward is anti-clockwise. Then if the pivot is here, any force upward on the left-hand side is clockwise. And any force on the right-hand side of the pivot will bring out anti-clockwise moment. So you can see, if you can see this is clockwise and clockwise, clockwise and clockwise. Clockwise and clockwise, clockwise and clockwise. Now, and we have been able to calculate the clockwise moments and the anti-clockwise moments. Now, if this system is at equilibrium, equilibrium is a state of balance. If it is in equilibrium, the sum of clockwise moments will be equal to the sum of anti-clockwise moments. So you need to note that. So if it is at equilibrium, the sum of clockwise moments will be equal to the sum of the anti-clockwise moments. That is at equilibrium. If this bar is at a state of balance, then the sum of clockwise moments will be equal to the sum of anti-clockwise moments, meaning that our F1 D1 plus F4 D4 will be equal to F2 D2 plus F3 D3. And this is what we are calling the principle of moments. And therefore we can state the principle of moment as follows. So we can say that the principle of moments states that for a system so that the principle of moment, it states that for a system in equilibrium, sum of clockwise moments about a point is equal to the sum of anti-clockwise moments about the same point. And this point that we are talking about in our case is this. It is the pivot, the point of support. So for a system in equilibrium, the sum of the clockwise moment, this clockwise moments plus this clockwise moments about a point will be equal to the sum of the anti-clockwise moments about the same point. And that's what we refer to as the principle of moments. Now, you can have many forces. You can have 2 forces, 3 forces, as many as you are given. But provided that you know that on this right-hand side of the pivot, the forces will bring about a clockwise moment. That is the downward forces. The upward will bring about anti-clockwise moment. On this side, anti-clockwise moment, clockwise moments being brought about by those upward forces acting on the left-hand side of the point of support or the pivot. So that is the principle of moment. It is going to help us in calculation of unknown forces. For example, if we had all the forces and the distances and maybe F2 is missing, we can now use the principle of moment to calculate the value of the unknown force or even the unknown distance. And we are saying that this will only apply. The sum of clockwise moments will be equal to the sum of anti-clockwise moments if only this system is in equilibrium. And we have seen that equilibrium is a state of balance. So when this system is at balance, then it will mean that the sum of clockwise moments about a point will be equal to the sum of anti-clockwise moments about the same point. So during our next lesson, we are now going to apply this principle that we have learned, which we are calling the principle of moments, so that we can solve some problems. And this principle of moment, what we have stated, is also called the law of the lever. It's also referred to as the law of the lever. That is the principle of moment. It is called the law of the lever, stating that for a system in equilibrium, the sum of clockwise moments about a point is equal to the sum of anticlockwise moments about the same point. So you should be able to state that principle, and then now we'll get into numerical problems. So I would like you to, as an assignment, I want to give you some 2 questions. So that's the first one. Calculate the moment of force about point P in the figure below. So you have point P and a force of 100 newtons. Then number 2, state the principle of moment. So during our next lesson, we are now going to apply the principle of moment in numerical problems. Thank you.